Hi, good morning everybody. Today in this video we are going to discuss about the next type of joints, that means welded joints. In the last video we already discussed about the type of joints in which the welded joints are those in which the two plates are connected by means of welding, right? And there are different types of welding, arc welding, then similarly gas welding, and the method of welding mainly two types. Butt welding, if the two plates are butt against each other, butt joint like this is one plate, the second plate. These two plates can be joined by bolting, riveting, or by welding, right? Here it will be welded here, this joint. So by welding here, the two plates can be joined. This joint is known as the butt joint. Two plates connected together end to end, and this is known as butt weld. Butt weld, B-U-T-T, butt weld. Or otherwise we can join as a lap joint. Consider a lap joint like this. Two plates are placed one above the other with a lapping distance, and these two plates can be joined by welding here at these two ends, here by welding to this one, welding like this, right? This is known as lap weld, right? So this is a permanently joint in which the two plates are placed together either end to end like this or as a lap, and these two plates are joined by means of welding, right? Now when we use these welded joints, it's a permanent joint. Here also we can find out the shear strength, the design shear strength of a welded joint. The last video we have discussed about the design shear values or shear strength of a bolt, right? And also the design or the bearing strength of a bolt. Now here in this case, if it is a welded joint, we can find out the design shear, that means the formula FWD. What is FWD? The design shear for the welded joint. That is why FWD, W for welding, is equal to FWN, that is the nominal, WN nominal divided by gamma MW, the partial safety factor. The same equation as we used in the case of bolting or riveting. Here is the design shear strength, the nominal shear strength divided by the partial safety factor. So this partial safety factor in the case of welding, so in bolting we have already taken the value of 1.5 as the partial safety factor, but here that depends upon the job carried out whether in the workshop or in the field, right? If it is fabricating in the workshop, then gamma MW will be equal to 1.25. If it is manufacturing in the workshop or fabricating in the workshop, 1.25. Otherwise the value will be 1.5. That means when it fabricates in the field itself, the value of gamma MW will be equal to 1.5. So while doing or while solving problems, the values, the corresponding values should be taken as 1.25 and 1.5 respectively, whether it is fabricated in the workshop or at the field, right? So here the same equation, design shear strength, the welded joint, is equal to the nominal shear strength divided by partial safety factor. This value, this equation and these values are given in table number 12, okay? Table number 12, page number 78 of IS 800 2007, right? These values of partial safety factor and this equation, okay? And from this, as in the case of bolted joint we already studied, from this FWN, the nominal shears can be found out from the formula Fu by root 3. What is Fu? There is ultimate tensile strength. Ultimate tensile strength of the welded joint divided by root 3. So first find out this Fwn using this equation, then substitute here Fwd is equal to Fwn by gamma W Mw, where gamma Mw will be equal to 1.25 or 1.4 respectively, right, as in a workshop or in the field. So that values are also given in table 5 page 30. Table number 5 page 30, these values are given. Okay, so you can refer the IS 800 also to get the relations and also the values of the partial safety factor as the case may be. Understood? So here also when we solve the problems, you can use this formula, these two formulas to find out the design shear strengths. So the next video we will solve the different type of questions or different type of problems from this welded joint. When the load is given or when the load is not given, how to find out the load by taking the relation and find out the design shear strength of the welded joint. Otherwise, different type of cases we will see in the next videos. Okay, thank you.